Good morning, grade 10. We are now in the um, examples. I'll be giving you examples for all the laws, gas laws that we had discussed earlier in our previous discussions. Aside from that, your problem solving 2 deals with different gas laws, right? We'll be unlocking all the difficulties. As of the moment, we'll be discussing the ideal gas law. No? Remember that there are three bases for these laws. For the ideal gas law, we have the Boyle's law, which is V is inversely proportional to pressure. Okay, volume is inversely proportional to pressure. Charles' law is talking about. By the way, for the Boyle's law, it's we have a constant N, and a constant N is for mole and constant T is for temperature. Okay, Charles' law is talking about volume is directly proportional to temperature. We have actually constant mole and constant pressure. Avogadro is talking about volume is directly proportional to mole. Remember the mole concept by Avogadro? Avogadro is more on concern with the moles per mole. Okay, we have constant mole, no? Constant amount of mole, even though these elements are changing, still it has a constant mole. We call that constant mole as Avogadro's number. Okay, we have constant pressure and constant temperature. Let's move now to the ideal gas law. Okay, if we're going to combine the ideal gas, we're going to combine all those laws by Avogadro, by Boyles, and Charles, we can actually create the ideal gas law, which is V is directly proportional to mole times temperature over pressure. Okay? Or we can have this one that V is directly proportional to R, which is proportionality constant. Okay? Because N times T over P is equal to R. So therefore, V is directly proportional to R. Okay? We can also have this one. So rearranging, we have PV is equal to N times R times T. Or P times V is equal to N times R times V times T. Wherein P is a pressure expressed in ATM or atomic pressure. V is equal to volume expressed in liters. N is moles, of course. T is temperature expressed in Kelvin. But if the question is asking about centigrade or Celsius, you need to give the Celsius. But if it is not actually asking for degree Celsius, then you need to convert that one into degrees Kelvin. R is the gas or proportionality constant. Okay? Again, for proportionality constant, since it is constant, let me check if I actually included it here. Since it is constant, it can be computed as 0.0821 liters per ATM over mole per Kelvin. Okay, so this is constant. Based on Avogadro's law and based on Boyle's, this is the constant or proportionality constant. Okay? When you say constant, it will never change because it's constant. Do you have any questions so far?
None.
Okay, let's continue. Okay, let's have one example. following this formula, PV is equal to nRT. Let me share my screen again. Let's have this one. This is really hard, no? That is why if this is face-to-face, it's really easy for us to discuss, to unlock the difficulties. This time, we are unlocking the difficulties, okay? But this is not difficult, no? Because a lot of you are talking about, sure, it's really difficult, the problem solving number 2. In dealing with lessons, we will start at the basics. And then, on the higher order thinking skills. That is actually the pattern. So you need to be used with the patterns in dealing with scientific problems and in dealing with the lessons, right? So let's have this one. A 500 ml bottle. Can you see my shared screen?
Yes, sure.
Sure, question. Why you usually give examples or limited examples? Well, talking about examples, I need to fish. I need to teach you how to fish. This is not feeding up. Okay? I want you to analyze on every examples that I had given. Animals. I need to double check if you really know the lesson or not, right? Because you are also one of my outputs. Okay, a 500 ml bottle contains hydrogen gas at 600 millimeter of mercury at 20 degrees Celsius. How many moles? We're talking about moles, so Avogadro. How many moles of hydrogen does the bottle contain? So since we're talking about Avogadro's law, we're talking about moles. So the ideal gas law will actually fit to it. Okay? Right? So first and foremost, we should first identify what are the given. Okay? Should start with the given. Why? If you will start with the given, maglibog na mo on what to do. Okay? Start with the given. We have pressure. What is the pressure there?
MM,
Six
600
600
mm
mm
Hg.
Hg.
Okay, 600
mmHg, teacher.
millimeter per hydrogen or per mercury. And since pressure in ideal gas law is talking about express in ATM, how can we express in atomic pressure? Okay, how can we express this in atomic pressure? We need to consider what? If we're going to express in atomic pressure.
Use multiplication or division.
Hmm? How can we express this one in ATM? Remember the STP? What is STP then?
Standard
Standard temperature and pressure.
temperature.
consider the standard temperature and pressure. Okay? The standard, the STP for pressure is 760, that's the constant, millimeter of mercury. So therefore, we need to divide this one since we need to get the ATM expressed in ATM, and we're talking about the moles of hydrogen. So we need to divide this one with the standard ATP. Okay? Di rin naman naglibog, no? The standard ATP. You didn't include the standard ATP. Okay? Because if you're going to directly substitute this one, tendency is you cannot actually get the exact answer since we're talking about mole. Okay? We need first to divide this one to the constant variable. Okay? Again, if it is in mathematics, it's constant variable. Like the
Wait, teacher. Teacher,
yes,
how did you get 760 again?
760 is the constant, or can we actually consider this one as the STP? Did I discuss STP in the previous discussions?
Yes, teacher, you did.
Okay. So the constant STP is the 760 millimeter of mercury. The reason why we need to divide 600 is that because we need to get the ATM. Okay? Or atmospheric pressure. Okay. There you go. Or, as what Trisha said, it's correct, no? That 1 ATP is equal to 760 millimeter of mercury, according to Boyle's law. Correct. Correct also. This is equal to 700 divided by 600 divided by 760. This is equal to 700. Let me have my calculator. 600 divided by 760. This is 0.78.
Teacher, 0.
0.7, and this is now ATM. Okay. Let's move now to the next. What is the next given there? It's the volume, right? What is the volume there?
500 ml.
500 ml. Okay. But we need to express again. Express again in volume. You need to express it in liters, right? Diba? Volume is expressed in liters according to the ideal gas law, correct? Since it should be expressed in liters, we need to convert this one into liters. Okay, how can we convert ml into liters?
We divide it by 1000.
Divided by, okay, 1000. Correct. Okay, 1000. So we have
0.5.
0.5 liters. Correct? Next is what is the next given there?
Temperature.
Temperature. Correct. The temperature is
20 degrees Celsius.
20 degrees Celsius. But since we need to convert this one into Kelvin, we will add, what is the
273.
273?
73.
Okay. This is equal to 293. 273 plus 20, this is 293 Kelvin. Correct? And what is the last given? The constant variable? Okay. Proportionality constant. Okay. What is the constant, proportionality constant again?
0.08206.
Okay. 0.8206. Correct? Or we can actually have 21 liters per ATM. Okay? Over per mole. Correct? Underline. Mole per 8 per Kelvin. Correct? Is that correct? Grade 10?
Yes.
Okay. We can now substitute. Okay? Following the solution. Following the formula, PV is equal to nRT. Okay? Since we're actually asking for or talking about, or the problem is asking about the N, we should what? What should we do next?
Um,
What?
We substitute the given.
Substitute the given? Okay, let's substitute the given first. What is the given pressure is? Point 789 ATM times volume is 0.5 liters is equal to N times the proportionality constant proportionality constant here is this one, times temperature is 293 Kelvin. Correct?
Yes.
Okay, what should be done next? What should be done next? Huh? Next is, di ba we're asking about the mole? Okay, so we need to transpose. N is equal to divided by, are you still following?
Yes.
Yes, teacher.
Correct? Tama ba?
Yes.
N is equal to, what should be done next? You can see actually the
Can we cancel the K?
yes, we try to double check on the formula, we try to double check on the solution. What should be done next? Yes, Trisha, correct. Now we need to cancel the liters, the ATM. What else?
Temperature. Kelvin.
The Kelvin, teacher.
What do you think will happen to this solution? We can actually cancel this one, right? Cancel ATM, cancel liters, and of course, cancel Kelvin. So what do you think will happen to this formula? Substitute
Multiply.
0.789 times 0.5. It 0.3945 over 0.821 times the degrees Kelvin, which is 293. It is 240.553 underline.
Oh, oh wait.
And we have mole. N is equal to, or mole is equal to
Wait, what?
Yeah, correct. Correct, Tisha. 821 times 293 Kelvin. It's 240.553. Tisha, it's 240.553. It is not division first. We look at this is a separate. Okay. Let me start the annotation. This is separate. Okay. This is your temperature, and this is your proportionality constant. This is your R. Correct? This is R. Tama? Okay. So your mole is equal to 0.3945 divided by 240.553. So the answer is your mole here is 0.0016 mole. Or you can have also 164 mole. Correct?
Wait, teacher, how did you do that again, teacher? Sorry, because my background was noisy.
Okay. Diba we started from here? Yeah,
Yes,
let's
teacher.
review. Okay, we started
Oh, wait, teacher, the one that you did with the mole, the one with the solving the mole.
Diba this is your R? This is
Yes.
let me start the annotation. This is the R, correct?
Mm, yes.
Value of R. And this is your temperature, correct? This is a separate one,
Mm,
correct? Okay. So what we did was
mm,
we actually multiply. This is multiplication, correct? We need to multiply the value of R, which is 0.0821 to 293 Kelvin. And we canceled actually the symbols. So we only have 0.3945 over, of course, the mole. We didn't cancel the mole, correct? Because we're looking for the mole, correct?
yes.
So we have
Yes.
0.3945 divided by 240.553 of mole.
Mm.
So the answer is 0.00164 of mole. That's the correct answer.
Okay. Thank you, teacher.
Okay. What is lacking actually in your activity is that you tend to forget to include the constant and the conversion, okay, and the and the standards. You need to consider that one, okay, and you can also make a note with regards to the formula or the standard formula being asked, okay. Like for example, for volume, what should be the formula? What should be what is in the volume? What should be included in the volume? In the temperature? Was it Kelvin or degree Celsius? all of those. Okay? Do you have any questions so far? If you're going to look at the formula, let's have this one, I will clear this one first. Clear all those. Diba this is our formula? Okay? PV is equal to nRT. What we did is actually this one. N, because we're looking at the mole, correct? N is equal to PV, correct? You look at the formula. We're just doing this one. PV is equal to proportionality constant times temperature. Simple. Mura na itong gibuhat. Everything. Correct? Okay, look at what we did. Pressure and volume, correct? R is proportionality constant. We have 0.821 liters per atm over mole per Kelvin and times temperature. Diba? Correct? Grade 10, are you still with me?
Yes. Yeah.
Yes, sir.
Okay. I will give you time to change your answer in our activities. Maybe by tomorrow. We'll be discussing tomorrow or the next day. When should we meeting? When is our next meeting? Let me check with my calendar.
Day teacher and Friday
Friday.
and also Thursday.
Let's unlock the difficulties by Thursday, and after which I will give you a chance to change your answers. Okay? All right? And I want you to interact, ask questions. Where did you get that one and all of those? Simply because I want a quality output for this school year. Okay? Aside from that, I'll be giving you also your performance tasks, your outputs for the entire school year. Because I did not ask anything, any project with regards to this school year, right? We should have an output, grade 10. And that will be included in the school's records, no? School's output. Diba I told you you're one of my output, correct? You're also one of the school's output. That is why. Right? Still have 2 minutes left. Do you have any questions so far, grade 10?
Nine.
Answer po.
Okay. Again, upon checking in your answers, it is really good, no? But the problem there is you didn't actually include the constants. What are the constants? And the conversion. So you need to convert first before using those, or else you might get a wrong answer. Okay? I think that will do for today, class. Thank you for your participation, grade 10. Hopefully also we can do the unlocking of difficulties by next meeting, and I will give you a chance to change your answer. I think that will be all. Thank you and have a nice day, grade 10. Goodbye.
Thank you. Goodbye.
Thank you, teacher.